Hello student, welcome to distance learning with Dipendra Acharya. In this video is for grade 8 student, and in this video we are going to learn about the introduction and a simple factorization on algebra. So let's proceed. Algebraic expressions, and this is the part first video on algebraic expression, and as it is on various part, I think in 4 or 5 parts, because if it is in single part, then I don't think it will be a shorter video. It will be a much more longer video, more than 5 hours, and definitely you won't enjoy it. So it's a part one, and we are going to study about algebraic expression. It's a great for grade 8 students. Now first we are going to study about algebra. We are in algebra, so what is algebra? Let's see the definition of algebra. It's a part of mathematics, just like it's a branch of mathematics, like arithmetic, algebra, statistics, probability, and many other things are there. And so it's a part of mathematics in which letters and symbols are used. Uh, they are used to represent number and their values. Symbols or letters are used to represent numbers and values in various formula and expression. You will come across formulas also. You will come across equation also uh, in grade 8. So let's move forward. This is the standard definition. It's a sort of a standard definition of algebra, and only student must keep note that it uses symbols and letters to represent the numbers and values in various formula and equations or expressions. After the definition, what we have to learn is we have to learn two terms, very important terms, variable and constant. And what is variable actually? Before going on to the definition of variable, let's understand it. Uh, there are four friends. Let me give you one example. There are four friends. So let us name them A. It will be easier. B and C and D. As they are on the side of a road, a busy street, you can say they are standing, or they are just sitting, or they are just chatting on the side on one fair evening, a very good evening of a hot day, and they are just watching the vehicular movement, because there are buses, trucks, lorries, scooter, bikes. They are just moving on the street. They are coming and going, and one of the friend among four, he he asked one question with all his friends, and his question is, can you tell me how many scooters passed through the street, or moved on the street, and while we were here, isn't it? Do you understand the question? How many scooters crossed on the street or moved on the street while we were here? Not whole day, while we were here. And for this question, his friend B answered that I guess it is 50 scooter. Okay, he guessed as 50 scooter, and C said I think it's 75 scooters. And what D said is I think it's X scooter. He said X scooter, and all of them look at A, because he is the person who asked the question, and what we think is those who ask the question knows the answer, isn't it? Now what A says it, B, you are not correct, you are incorrect. C, you are also incorrect, because the number of scooter that passed through the street while we were here is not 75. And what he says to D is, you are correct, my friend. Okay, D is correct. And B and C obviously protested, and they argue with their friend A that why, because D even didn't give any number, isn't it? B and C just said a number, isn't it? They gave a number 50 and 75, but D, he just said it's X. And A explained his friend that X can take any value. X can take any value. It can take the value of B, 50, that is, isn't it? X can take the value of 75, that is of C, and X can take the correct value also. Okay, x can take the incorrect value also, x can take the correct value also, x can take the any number of value. If we ask the person which who are passing on the street, they can give the another number, isn't it? They can say that okay, they can have their own number, and x can take the any number. So there is 100% chance that x will take the correct number also. So that's the reason why A said D is correct, because his answer x is a variable and it can take any value, isn't it? And if it can take any value, then it will take the correct value also. X can take any value, x can take any number, then it will take the correct number also. There is a correct number, isn't it? As nobody are counting, but there is a number, there is a certain number which is correct, and x is a variable and it will take the values. So if we say, if we are not sure about the answer, then we can say x, isn't it? X will always take the value and it will take the correct value also. So there is a high chance, there is a, I think it's 100% chance that it will take the value, means it will take the one value that will be correct value. It will take one answer that will be correct out of many answers. So x is variable. So let's see the definition. I think hope you understood that what is variable. Variable actually is a letter or a symbol and which takes more than one value. So uh, so a discussion of the friend ended, it is concluded, and all B and C, those two friends who protested, also agrees that x is the correct answer, because it takes the value and it will take the correct value also. Let's see the definition. A letter or a symbol, it's for variable. A letter or a symbol which takes more than one value is called variable. Now the example you can see A, B, C, X, Y, Z. They are the variables, and they are the example of variables actually. Now there is another word, constant. To understand this, let's take one example that in town, and most of the town there is to be, I think, I don't know right now, but in past there used to be a 99 sub, 199 sub, 299 sub. What does it mean is whatever you take from the sub, it costs only 99 or 199 or 299. That is the example of constant, is it? Every whatever you buy from that, whatever you uh, take from that shop, you have to pay just 99 rupees. If you take a coffee mug, 99 rupees, and if you take a hat, 99 rupees. If you take a flower vase, it will cost only 99. So that's the example of constant. Constant means uh, anything that has a fixed value, isn't it? Constant is fixed value. It will be fixed for you also, it will be fixed for other also. Whatever you take from the shop, that is fixed, so it is a constant. A letter or a symbol having fixed or unique or definite value is called constant. If you go to a vegetable shop and you ask the shopkeeper that how much does this potato cost, then he will say 100 rupees per kilo. And how much this carrot cost, he will say 100 rupees per kilo. How much does it radish cost, he will say 100 rupees per kg. Then that means the price on the shop for each and every vegetable is 100 rupees. That is constant. The price of vegetable in the vegetable shop is constant. So constant means fixed, isn't it? Having fixed or unique or definite value. Fixed, unique or definite value is called constant. So hope you understand variable and constant. So you can pause the video and you can write, you can note it down on your copy. Now example of constant is for any number like 6, 10 and 5. They don't change their value. They are constant. They are 6 is 6, is it 10 is 10, minus 5 is minus 5, etc. They are constant. Now Tom, we have to learn this Tom also. Plural, it's written Toms. And as you have studied algebra in class 6, 7, 5, 6, 7, isn't it? So I hope you have came across this 2x y minus 4xy. It's written, you have seen on your book, you have done addition and subtraction of these values, isn't it? You have studied about the like and unlike term, you have arranged it, you have subtracted it, you have multiplied it also. So you have seen written like this, 2x comma y or minus 4x square or y to the power 4 z 7 etc. Now if you have seen this, then that's what term is. Okay, in plural they are terms. Now these are terms. 2xy is a term, is a single term. Minus 4x square is a single term. Y to the power 4 is a single term. Z is a single term. 7 is also a term, etc. They are all terms. They are all terms and each and every are term. So term is we can conclude this: a single number like 7, 24, etc. If we if you consider these numbers, they are also a term. Okay, and listen closely, they are terms. Variable like xyz, abc, minus d, they are also term. We can call them term. And a variable repeated more than once, see, it's a variable x. If I repeat it twice, then it will be x square, isn't it? There is a variable y. If I repeat it 5 times, then it will be y to the power 5, isn't it? There is a variable 6 c, and if I repeat it thrice, it will be c3. Now they are also called terms. So we can call them these x square, y to the power 5, c to the power 3, etc. Terms. You can see here x is repeated twice, isn't it? It's repeated twice, its power is 2. Y is repeated 5 times, and c 3 times. Y is repeated 5 times, and c is 3 times. Now these are also terms, and like 7, 24, 8, they are also term. xyz, it's z, xyz, a b c d, they are also term. If it is a minus, if there is minus also, it is also term. And variable repeated more than once, that x square, y to the power 5, c to the power 3, they are also terms. And another here you can see a number multiplied a single value like 4x minus 5y etc. They are also terms. If we multiply number, there is a number 7, and if I multiply with this with x, then this is also term. 7x, it is also term. We can call it is a single term. And an other way, if I multiply minus 8, which is right here, you can see minus 8 times c to the power 3, then it is also a single term. Okay, now etc also a term. You can see a number and more than one variable. If there is a number 7, there is a number 7 in our example, you can see there is right here 7. And if I take x square, and if I take y, x square from here, right here, I took 7 from here, x square from here, and y to the power 5 from here, and c from here, y to the power 5 and c from, and this is also a term. Okay, I think you understood it. Y 7, x square, y to the power 5, and c is also a term. We can call them a term. So hope you understand what terms mean, term or terms means. And let's move forward. You can pause the video, you can note it down on your copy, make the note properly. It is very important and it is very helpful also. Let us consider these following terms. We have these terms, we have randomly picked these terms: 2x, y minus 4x square, y to the power 4z, and 7. These are terms. And you need to remember, these are the basic operations, basic operator, you can say. Addition, subtraction, multiplication, division are called basic operation. And these plus sign, minus sign, multiply sign, and divide sign are operators. There are 4 operators, and they are plus, addition, subtraction, multiplication, and division are basic operations. Now remember this, and you can see the various terms which are right here, and the same terms are here. These are various terms. Now what we are going to do is, just see, we are going to combine, we combine by basic operations like addition and subtraction. We are going to combine these terms by addition and subtraction. Okay, just understand it. We are going to combine these 4 terms, 1, 2, 3, 4, 5 terms with the help of addition and subtraction, or plus or minus operator. Now what will happen? We get, see what we get. We are building towards something special. Okay, so pay attention. 2xy minus 4x square, we just combined it. Okay, we use the negative operator, which was already here in the question, so we don't have to apply another one. And we a minus operator, and plus right here, minus plus, you can use any way, you can do it, and as in, you can do on your own also, on your own style also. So what happens when we combine these terms with the basic operators like plus and minus operator, and we, then what will happen? We are building towards a very special thing, that is algebraic expression. Now that's what algebraic expression is. Algebraic expression is nothing but a combination of terms. Algebraic expression is nothing but a combination of terms, and they are combined by basic operators. Here we have done with the plus and minus, but you can do with divide and multiply also. Okay, so algebraic expression is nothing but a combination of terms using basic operators. Okay, let's see the definition. Definition is algebraic expression is a combination of terms using four basic operations. If we apply the operation between the terms, then it is an algebraic expression. Okay, if we apply the operators plus minus division and multiplication, if we apply operators between the terms, then that the result will be a algebraic expression. So this is what algebraic expression means. It is nothing but a combination of terms. Let us study these examples of algebraic expression. Now, what is algebraic expression? We knew what is algebraic expression. Now we have to let's see the example of algebraic expressions. Now there is a table where there will be algebraic expression, and we have to count the number of terms, and according to the number of terms the name will be given, and there is a remarks also. Let's see the first one. Now how many terms are there? How many terms? As you have already studied about the term, you can say that this is a single term, isn't it? And minus 4 alone is also a term. Z square alone is also a term. But if they combine together, minus 4z square, that they will be a single term. Okay, don't get confused. It won't be two terms. It will be a single term because it is a multiplication. It is multiplied, or it is times. No, minus 4 times z square. So it is a single term. Number of terms is 1. We can clearly see there is only one term, and it is a monomial. If algebraic expression has one term, if algebraic expression has only one term, then it is called monomial. And mono means, it is a Greek word. Mono means one. Okay, mono. Monopoly means it is just a one man show. Okay, mono means one. So I think you understood it. Monomial means any algebraic expression having only one term. And don't get confused. Here there are minus 4 is a single term, z square is a single term, but if we combine them, minus 4 times z square, then it will also be a single term. It won't be two terms, it will be a single term. Now let's see here how many terms are there. How many terms are there? There are two terms. There are two terms, and two we can count. There are only two terms. Binomial, if algebraic expression has two terms, then it is called binomial. So if algebraic expression has two terms, it has its own name, and it is called binomial. Bi means two. Okay, bi means two. Mono means one. Bi means two. Now three, you can clearly count. There are three terms, isn't it? You can clearly count there are three terms. This is one term, this is a two term, and this is a three terms. As we have already studied about the terms, then you can easily distinguish there are three terms. You can easily notice, you can easily observe there are three terms, and it is called trinomial. If the algebraic expression has three terms, then it is called trinomials, and tri means three. Okay, triangle, there are three sides, so it is a triangle. There are three angles, so it is a triangle. So bicotyledon, monocotyledon, isn't it? Having, you have studied on science also, bicotyledon, monocotyledon. So mono means one, and bi means two. So if the algebraic expression has two terms, then it is called binomial. If the algebraic expression has three terms, it is called trinomial, and if the algebraic expression has one term, it is called monomial. So you can pause the video, you can note it down on your copy. To another, there is one term, polynomial. Okay, poly means, what is poly? Poly means many. Poly means many, and nomial means nomial. Only nomial means name, or in mathematics you can say terms. You can call many names, or you can call many terms. So for us it will be better to call terms. Okay, many terms. Polynomial means many terms. Let's see the definition. If an algebraic expression has two or more than two terms, then it is called polynomial, or somewhere it is also written as multinomial. Expression having more than two or more than two or more than two terms or many terms having polynomial algebraic expression having many terms is called polynomial. So you can see poly means many and nomial means terms, or you can say name, so it becomes many terms. Okay, polynomial is also important. Now we have to study about the degree of algebraic expressions. Now to find the degree we only consider variables and their power. We consider variable and power. The coefficient attached with uh, it is not considered. Okay. Now, to find the degree of monomial, mono means one term. So now you need to understand this thing. Here x to the power a, you can say x to the power a, x is base, isn't it? X is base and a is power, or we call that index, as we are going to study in indices uh, later on. So we just need to know understand that x is base and a is power, and to find the degree of any algebraic expression we need to uh, we need to be clear about the power or index. So let's find the degree of monomial. Monomial, this is a monomial, isn't it? It is 4 times x square y and z cube, and x is base, its power is 2, y is base, its power is 1, if there is nothing then it's 1, and z is base and its power is 3, isn't it? So we have to consider only base and their power, base and their power. So we have, you are, I think you are clear about the power. There is 2 for x, 1 for y and 3 for z. Now let's see here. Now sum of power of x by z. Now x has 2 power. The power of x is 2. You can see right here. Power of x is 2. Power of y is 1. If there is nothing, then it's 1. And power of z is 3. Let's add it. Then 2 plus 1 plus 3, that is 6. Now what will be the degree of monomial 4x square yz cube? It will be, degree will be 6. Now you can write there degree of 4x square yz cube deg, and inside the bracket the algebraic expression or monomial, and you can write equal to 6, or you can write in a language also. So I think you I think it's clear. To find the degree of any monomial we just have to add the power of variables. Now you can easily find the degree of this monomial also. If it's written x to the power 3, y to the power 7 and z. Now what will be the degree of this monomial? Now let's add, first let's add the sum of the power. It will be 3 plus 7 plus 1, isn't it? 3 plus 7 plus 1. Now the sum is 11 and the degree will be degree of x cube y7 and z. The degree of x cube y7 and z is 11. So it's for monomial. Okay, this is technique is for monomial. For binomial it will be different. It will be different. Okay. To find the degree of binomial, the same thing will be shown here. And now this is the power and this is the base. X is the base and a is the power. We have to consider variable and their power only. Now this is example which you have already seen this example, and this is the example of binomial. It has two terms, and let's divide this binomial into two monomial, isn't it? Now if we consider only x cube, then it is a monomial, and if we consider only minus x cube y, then it is also a monomial. So there are two monomial. In a binomial there will be two monomial. In a trinomial there will be three monomials, isn't it? So we have two monomial. Let's separate them. Now you can see a monomial x cube, and we can easily find the degree of this monomial. Now sum of power of variable, there is only one variable, so it is 3, isn't it? Now we don't have two variable, it has only one variable, so its power is 3. Sum of power of variable is 3. Now let's see for another monomial which is minus x cube y. It has two variable x and y, and the sum of the degree sum of the power of variable x and y is 3 plus 1, isn't it? X has power 3 and y has only power 1. So the sum is 4. Now what happens is the degree of this binomial will be 4. Then why 4? Why not 3? Because the degree of monomial is the greatest power of its monomial. Now, what is the greatest power? 3 or 4? 4 is the greatest power. So, for the degree of any algebraic expression, we have to take the highest power of any monomial inside it. There are two monomials, and this monomial has a degree 3, and this monomial has a degree 4, and for the entire binomial, the degree will be 4. So it only takes the highest power. Okay, the highest power of any term, the highest power of any term inside binomial or trinomial will be the degree of that binomial or trinomial. Now we take the greatest power as degree of algebraic expression. Now among these two, the greatest power is 4, isn't it? So 4 is the degree of this binomial, entire binomial. Okay, understood? If you understood binomial, the degree of binomial, then you can easily understood the binomial degree of trinomial also. To find the degree of trinomial, now this is very important, so it is written everywhere. A is power and x is base. Okay, now we have to consider only the power of a variable. Now let's consider a trinomial. This is a trinomial. It has three monomials, isn't it? There are three monomials. This is a monomial. It is a monomial. It is a monomial, and it is a monomial. Trinomial is a combination of three monomials. Now let's divide this trinomial into three parts. Let's consider the first monomial, that is 2x square y. 2x square y is a single monomial. So let's consider and let's find the sum of the powers. Sum of the powers of variable. Sum of power of variables, that will be 2 plus 1, it will be 3. Isn't it? X has the power 2, y has the power 1, so it will be 3. Now for another monomial, minus 5xy, and now x has power 1, y has power 1. Now what happens there is sum of power of variables is equal to 1 plus 1, that is 2, isn't it? Now it's 3 for first, 2 for second. Now let's consider 3. It's also a monomial, it's also a term, and it is a single term, so it is a monomial. And how many what will be the power of sum of power of variable? As there is no variable, then it will be 0, constants or no variable, contains no variable, so it's the power of variable will be 0, or you can say it has x to the power 0. You have studied in indices, this its value also will be 1. Okay, we don't have to go toward this part. It is also 1, so its degree, its power is 0. So if it is a constant, then constant does not include any variable, so the degree of the sum of the power will be 0, isn't it? So degree of this monomial will be 0. Now we have three different sum of power of variables. That is, first is 3, second is 2, and 1. And among these, the highest one is 3, isn't it? Now we can clearly say that for this trinomial, the degree of trinomial will be 3. Let's conclude it. Now degree of this given trinomial is 3. We take greatest power as a degree of algebraic expression. The greatest power obtained from the sum of power of variable is 3. So because of that, our degree of our trinomial is 3. In a simple sense, if we do another example, if x cubed y is given, and minus 7x z to the power 2 and plus 3, and we can easily and quickly also we can say the power of x is 3 and power of y is 1. So this term contain power 4, isn't it? For this, it is power is 4, and for this, let's see, y has 1 power and z has 2 power, then it is 3. And as 3 is constant, then its degree is 0. Now among these 3, we can say the degree of trinomial is 4, because the highest power is 4. Now, okay. While doing while solving the question, you don't have to make all this drawing, and you can, it is only for the purpose of understanding. You can do in this way. Okay, you can do in this way. You can use a pencil to write this power 4 or 3 plus 1 4 or whatever you do. Just write, after finding this, write, just write degree deg and the trinomial inside it and equal to 4. Now that's the simple way to write the answer. Degree, and inside this whole entire algebraic expression, or you can say polynomial also, or trinomial, right here, and write equal to 4. Now that's the simple, isn't it? Next, we move to the very important topic, that is just like whatever we studied up to now in this 30 minute. That is, it is part of revision, and the question will be asked. Also, a very short question will be asked. And but here now we are on to the uh, very important topic, all factorization of algebraic expression. You need to understand what factorization is first. As you have already understood about the algebraic expression, you know what algebraic expression is. It is just a combination of terms, isn't it, by operators. What is factorization? Now let's see it. Now let us consider an algebraic expression of degree 3. If you wonder what does it mean, is we are just considering an algebraic expression having degree 3, and we represent that by ax. Now x inside the bracket, small x inside the bracket, means the algebraic expression is on variable x. It only includes variable x. It is x to the power 2 minus 4x. You can see this is the example of ax. You can see, you can take this as one of the example of ax. Okay, now let us consider ax as an algebraic expression of degree 3, and let us consider that these are the parts, these are the multiple parts of this algebra. Multiple parts means if we divide them, if we separate them, not in the sense like separation from the operator, like 3x is a one part, 2x, no, it's not like that. It's a different part. Okay, what is that different part? We will learn, you will understand later on. Now right now, just understand these are the three different parts of ax. It is separated from ax, it is acquired from ax, and now these are the multiple parts of ax. And like we take a plank of wood, and if we cut it on three pieces, we make them a three pieces by cutting it. Same thing. Okay, ax is a plank, and we cut them into three pieces, and first piece is a1x, second piece is a2x, and third piece is a3x. Now what happened here is, if we multiply them again, and if we get the original ax, then what we conclude sorry, what we conclude is that these a1x, a2x, these multiple parts are called factors. Why they are called factor? Because if we multiply, if we again recombine them, then if they give the original algebraic expression, then they are called factors. In case of the plank, also there is a plank. This is a long plank, and if we divide this plank into three parts, and while cutting, you have seen while cutting the dust falls, isn't it? Dust falls, and if we recombine that plank of wood which we have separated into three pieces, then we are not going to get the original plank. Is it because the length will be smaller? Maybe the area will be smaller, maybe volume will be smaller, maybe size will be smaller, weight will be lesser because of the dust particles. We can all recollect all the dust particles that are thrown on the air, that are moved, that are separated from the wood, and we can acquire those dust particle. We can collect those dust particle and combine them. We can reuse them to make a single plank of wood. So these pieces of plank, which are separated from the plank, are not the factor of plank, because they don't give the original plank if they are combined. So to be the factor, those factors, while after combining, must give the original algebraic expression from where they were separated, isn't it? So factors are those terms, we can say those algebraic expression. Factors are also algebraic expression. If after they are combined, if they give the original algebraic expression, then they are called factors. Those multiple parts of ax, after we combine those multiple parts, and if they gives the original algebraic expression, then we can say they are factors. Like in arithmetic, what we did in arithmetic is what we did in arithmetic we will see on the next slide. Let's for here the process of finding the factors, that process. There are many processes. Okay, now, there is not a single process. There is not only one process. There are many processes. There are different processes, and that process of finding the factors is called factorization. From a single algebraic expression, and we find uh, the factors. That the process of finding the factors is called factorization. What is factorization? It is just a process of finding the factors. And what are factors? Factors are those algebraic expression. Uh, After combining those algebraic expression, if we get the original algebraic expression, those algebraic expression, if we combine them, then if we get the original algebraic expression, then the parts, these parts, they are the parts of algebraic expression a, and they are the parts of algebraic expression ax, and if we again combine them, if they are able to give the original algebraic expression, then we can call them factors. Now, if we take one example, if you are still confused, and let's take one example of monomial. From monomial, now it is x square and y, and we can call x square and y are the factors of, we can call x square and y, there are two factors. Okay, there are two factors, x square and y. If we multiply this x square and y, again what we are going to get, that is x square y. Now what we can say is x square and y are the factors, they are the factors of x square y, isn't it? Now factorization is a breaking down of single algebraic expression to multiple factors, isn't it? Now so it's a simple definition. Factorization is a breaking down of single algebraic expression, that is ax, into multiple factors. You can see a1x, a2x, and a3x, they are the multiple factors. The entire process of breaking down of single algebraic expression into multiple factors is called factorization. Now we will consider an example from arithmetic, then it will be very clear to you. Recall what we did in arithmetic. Now let's factorize 42. Let's factorize 42. How we factorize? We do in this way, isn't it? See, now 42 is divided by 2 because it goes by 2, and its value will be 21. Now again 21 goes by 3. It doesn't go by 2, so we have to take 3. It goes by 3 7 times. 7 times. 7 again, if we divide, it goes by 1. Now what we can conclude here, 2, 3, 2, 3, 7 and 1 are the factors of 42. Why we call them factor? Will they give, if we multiply, if we combine these factors together, will they give us a original term 42, original number 42? Let's see. As 2 into 3 into 7 into 1, that is 42, isn't it? Also 2, 3, 7, 1 are prime factors, and process is called prime factorization. It's done on arithmetic. They are the process. This process is called prime factorization process, isn't it? Now, I think it's clear to you that these values 2, 3, 7, and 1 gives the original number 42. If after combining them, then we can call 2, 3, 7, and 1 factors of 42. Okay, I think it's clear what factor is. Now the process is called factorization. It is a prime factorization. It is in arithmetic we call it a prime factorization. And now let's move to another. As you have understood what factorization is, now let's start factorization of monomial. Let us consider a monomial 5x square y cube z. Now this is a monomial. It has only one term, so it is called monomial because it has only one term. Now this is a single term. Now it is called monomial. Now let's factorize it. We can write 5. If we factorize 5 by prime factorization process, then we have to write 5 here, and it goes only by 5 as it is a prime number, and 5 and 1. So the factor of 5 is 5.1. So we can write 5.1, and as you can see, x has power 2, so it's repeated twice. Y has power 3, it is repeated thrice. And z has power only 1, z has power only 1, so it is written only 1. So there is explanation for you. And this is the factorization. Okay, now this is the factorization of our given monomial. See the expression, 5 is written as 5.1. X square means we have to repeat x twice. Y square means we have to repeat y thrice. Y cube means we have to repeat y thrice. And z means it is written only once because it has only one. Its power is 1, its index is 1. So this is the factorization. And if we multiply this, if we multiply these factors, these all are factors, then we can get the original algebraic expression, original monomial. And let's move to another. Now let's move to another example. Now there is 12p square q3. 12p square q3. First let's factorize 12 by prime factorization process. Now 12, it goes by 2. Now 6 times. Now again 6 goes by 2 3 times. 3 times. And 3 is a prime number, so it only goes by itself, that is 3. 3 1 is 3. Now 12 can be written as, you can see 12 can be written as 2.3, 2.2.3.1. These are the factors 2, 3, 3 and 1. 2, 2, 3 and 1. 2, 2, 3 and 1 are the factors of 2, 2, 3 and 1 are the factors of 12. Are the factors of 12. Right here. 12. Now so p is square, so p can be repeated twice, and q to the power 3, then it must be repeated twice. Now this is the factorization. This is the factorization, and if we multiply this, then we will get our original algebraic expression, 12 p square q3. Again, let's do another example also. Minus 80 a to the power 3 b square and c to the power 3. Now let's factorize 80 by method of prime factorization method. Now 80 goes by 2 40 times, isn't it? 40 goes by 2 20 times, and 20 goes by 2 10 times. 10 goes by 2 5 times, and 5 is a prime number, it goes by only itself. So see, now all these factors, all these are the factors of 80. Factors of 80. There is a minus sign, so we have to include it. And as a is a cube, we have to repeat a thrice 3 times. B has power 2, we have to repeat twice, and C has power 3, we have to repeat thrice. And if we multiply all these value, all these factors, then we will get the original monomial. Minus 80 a cube b square c3. Now hope you understood the factorization of monomial. Factorization of monomial will be very important on factorization of binomial. It is very important. This process of factorizing monomial will be very important while we are factorizing binomial and or trinomial. Factorization by taking common. Now first we will do with binomial. It's type 1, section A, and including binomial and trinomial. Let's move. So let's start example 1, and it is a factorization of monomial 6x plus 3. Now while factorizing the any monomial or trinomial, we have to focus only on this red 6x first and then this blue 3. Let's only focus on 6x. Let's try to factorize 6x first. Here 6x plus 3 is our question. Now only our focus is only on 6x. So let's see. It has a 2 terms, so it is a binomial, which we already know. Let's only focus on 6x. 6x is factorized at 6.3.1. By the process of prime factorization, we can do it by the prime factorization. You can see it's a 6, and it goes by 2 and 3 times, and 3 is a prime number, so it only goes by itself or 1. So instead of 6, what we can write is, we can write 2.3.1, and the power of x is 1, so x is written only once. So let's replace 6x by 2.3.1.x. 2.3.1.x. Now for 3 is just a prime number, so 3, if we factorize it by the prime factorization also, that is 3, only it goes by 1, so 3 can be written as 3.1. 3 can be written as 3.1, so plus 3.1. Now we can easily see isn't it? In these two terms we can easily see there are values which are on both terms. You can see 3 is on both terms, isn't it? Right here, which is circled, 3 is in both terms. 1 is also there, but let's focus on number other than 1. Okay, 1 is also there, but we are going to focus only on the number other than 1. So you can see 3 can be seen on both terms, so 3 is a common value. We have to understand what common value means. Common value means that value which is on the both term. If it is present on the both term, if we can see it on the both term, then we can say that value is a common value. So in here, right here, it's 3. There is 1 also, but let's focus on number other than 1. 1 is also common, but 1 is not taken as common. 1 will be common value when nothing is common. We will only consider 1 when nothing is common. We will come across that question also, that type of question also. So let's see, 3 is common, and we have to separate that common value. That common value must be separated from the other values. Okay, and from this part we have to separate 3 and bring outside. You can see 3 is here, right here, it's outside of the term, and this 3 will also be outside. Now inside the bracket, these values are the remaining value after 3, isn't it? You can easily see 3 is outside, then 2, 1 and x. And here what happens? 3 is outside, then only 1 is inside. So let's multiply. What will be the product of 2 dot 1 dot x? It will be 2x. It will be 2x and plus 1. So this is the factorization of monomial, isn't it? It's easy. It's very easy. Now let's see an example. It's of trinomial. There are 3 terms, so it is a trinomial. Now solution. As we did on binomial, we are going to focus only on one term at a time. Only on one term at a time. There are 3 terms. Our entire focus will be on one term, and then on another term, then on another term. Let's do it. This is our question. Let's focus on this red 2x square. Okay, this red part 2x square. Now it is a trinomial. It is a verification that it is a trinomial. It has 3 terms. Now our focus will be on 2x square. Now 2 is a prime number, so 2 can be written as 2 dot 1, and x, the power of x is 2, so we repeat x twice. Now instead of 2x square, what we are going to write is 2 dot 1 dot x dot x. 2 dot 1 dot x dot x, isn't it? Now our focus will be this on green 2x cube. 2x cube, as 2 is already we have said it is a prime number, so 2 can be written as 2 dot 1, and x, the power of x is 3, so x is repeated thrice. Now instead of 2x cube, we are going to write 2 dot 1 dot x dot x dot x. 2 dot 1 dot x dot. Now this, it is a factor of this part, it is a factor of this. Now for 8x to the power 4, let's see, 8 can be written as 2 dot 2 dot 2 dot 1. How? Let's see. Let's do by prime factorization method. It's 8 right here, and it goes by 2. Now it will be 4 times. Again it goes by 2. It to 2 times. Now again 2 goes by 2 is a prime number, so 2 goes by 1. So instead of 8 we can write 2 dot 2 dot 2 dot 1. And as the power of x is 4, we can see x is repeated 4 times. Now let's replace x to the power 4. X to the power 4 is replaced by these values, isn't it? Now just see clearly what's the common value. You understand, you have already understood what's the common means. Now you can see easily the common. Let's circle it, or let's circle it. Now 2 you can see in all 3 terms now, so that we can say that 2 is common, isn't it? Now, and x is also there. X is also there on all 3 terms, isn't it? Now see, this x is there right here. This x is also there. Here is also x. Now this is x is also common. There is another x on all 3 terms. There is another x on all 3 terms also. So let's see. Now this x, and this x. Now these are the common values. Other here is one x and here is one x, but they are not common. They are common between these 2 terms, but not on the entire trinomial. We have to take common from the entire trinomial. So don't take common. This x is not common. Okay, these are common, but only between these 2 terms, but not on entire trinomial. It must be common on entire trinomial. Now what we have to do, this common, we have to separate them from the other factors, isn't it? Other factors of their term. Other factors of their term. So let's take common 2x. X is common, isn't it? 2 is common right here. You can see x is common. X is common in from all. You can link with arrow also. In 2x, x is common. Now the remaining will be written on the bracket. Inside the bracket, 1 is remaining. You can see clearly 1 is remaining from the first term. 1 and x is remaining from the second term, which 2.2.1 and x.x is remaining from the third term. This 2.2.1 and x.x is remaining from the third term. Now see here, you can clearly see, and let's multiply it. Now here there is explanation. Common must be on all terms. Yes, common must be on all terms. Entire common must be on all three terms. Okay, if we are considering trinomial, then the common must be on all three terms. Now let's multiply here. 2x square, isn't it? The product of 2 and x dot x, that means x square. 1 is will be written as 1 as it is. 1x is x, and 2 into 2. This 2 into 2 is 4 right here, and x into x is x square right here. Now this concludes our factorization of trinomials. Uh, let's move forward. These are questions for you. You can do these questions. You can practice this question, entire all questions. There are 33 questions, I think, and this you can this up to here. It is example one. Up to here, you can follow example one, and after that you can follow example two. Example two. Example two, and this is example one. Now let's move from trinomial to polynomial. Now section B, if you have remembered, then it is a section A. We conclude section A, and section B includes 4 terms. We will arrange the term and we take the common. And taking the common, these things, this process will be done on section B. See, example 1 of section B. Now this is the factorization. It includes 4 terms. Then we can call this a polynomial, and solution here. Now this is the question. Ax plus bx plus ay plus by. We can arrange the terms as ax and ay. We can keep this ax and ay together, and bx and by together, and we can take common, or we can do as it is. Okay, we can do as it is. Now let's factorize the each and every terms here. Ax, we can factorize ax. Please note, if there are 4 terms, then we have to take common from first two and last two. Okay, now the process of taking common, it is different from the trinomial. In trinomial, we have to take common from all the 3 terms. But if there is a 4 terms, if it is a polynomial, then what we can do is we can just take common from the first 2 terms and from last 2 terms. Okay, in case of, it is only in case of uh, this sort of uh, this sort of process is done for 4 terms. A polynomial or algebraic expression having 4 terms. Let's see, let's factorize first. A dot x, isn't it? Ax can be written as a dot x, and bx can be written as b dot x, and ay can be written as a dot y, by can be written as b dot y. You can see by the color, this brown color, x with the brown color are common from first 2 term, and y with the red color are common from second last 2 term. So we can circle it also, isn't it? We can circle, this is common. If there are 4 terms, then we have to take common from first 2 terms and last 2 terms. From first 2 term, you can see x is common from first 2 term. X is common from first 2 term. Let's write x a plus b. From first 2 term, x is common. Our x is common here. See, x is common, and we have what we have to do. The common value we have to take out from the rest of the other value. So we took it out. That is x, and remaining is written inside the bracket. A is remaining from the first one. You can clearly see, and b is remaining from the second 2. Now let's do the other 2 part. Y is common. You can easily see the y, and red y is common. Red y is common. Y is common, and you can see the remaining a plus. You can see the remaining a and B, A and B inside the bracket. Okay, this is not the line. A and B inside the bracket. Remaining part will be inside the bracket, and common must be separated from the other. Common must be taken out from the other. Now please note, our 4-term quotient changes to 2-term quotient. Now right here, how many terms are there? You can see there are only 2 terms. This is the 1 term and this is the 2 term. Now our 4-term quotient, now it is changed to 2 term, and from 2 term also we can clearly see A plus B is common. Isn't it? Exactly. A plus B is common. Now what we have to do, the common value, we have to take it out. We have to take it out from the rest of the other value. A plus B is common, so it is taken out, and the remaining X with and remaining Y are written right here. Isn't it? This, it is not the line. Remaining X and remaining Y are written. Now this is our factorization. This is the conclusion of our factorization. Or we can do by the another way, we can arrange the term. Now our question is AX plus by. You can do in another way also. B x ax plus bx plus ay plus by. It is our question, and what we can arrange it, how we can arrange it is by with a and a can be written together. Ax plus ay, ax plus ay will be written together, and bx and by is written together. Bx, it is arranging term. By written together. From first 2 terms, you can clearly see A is common. We have to take, if there are 4 terms, then we have to take 2 terms at a time. So A is common, you can clearly see. And what we have to do with the common value, we have to take it out from the rest. And inside the bracket, we have to write the remaining A plus Y. So it's remaining, plus sign, it's there right here, plus sign. And what you can see from the last 2 terms is B is common, isn't it? B is there on both terms, so it's common. What we have to do, the common value, we have to take it out from the rest of the other value. X plus Y is remaining. Now what we can say is our 4-term quotient is now changed to 2 term, and from these 2 terms also, this is 2 term, this is a single term, and this is also a single term. So from these 2 terms also, X plus Y is common. You can clearly see, isn't it? It's there on the screen. It's there on the screen. So X plus Y is common, and it's common and it's taken out. And what are the remaining? What are the remaining after taking X plus Y common? The remaining are A plus B. So in any way, we will arrive at same answer. So hope you understood it. And there is one more example for you. You can pause the video. Now let's see, 2a square plus 5a minus 6a minus 15. Now this is the question, and it is little bit different from the previous one. Now here we are going to arrange the terms. Now 6 is 6 and 5 here, they interchange their position, and while they interchange their position, they carry their sign with them. Okay, they carry their sign with them. And why we did this? Because 2 goes with 6, isn't it? 2 3 is 6, and 5 goes with 15. And also for another purpose, to avoid the minus sign here in the between, and it will create uncomfortable situation for the student, because they tends to make mistake in that part. So just to avoid the minus sign also, there are 2 reasons for the arranging. It's first, they goes with 2 goes with 6 and 5 goes with 15. So you can understand in that way also. uh, what we did here is rearranging 5a and 6a. Now let's factorize. Let's factorize on each and every term, single term. And 2a square is factorized as 2a dot a. 6a is factorized as 2 dot 3, as we can already we have already done that. 6, if we factorize 6 by 5 factorization process, then the factors are 2 and 3, and a and 5, 5a, 15, 3 dot 5, isn't it? If we factorize 15 by prime factorization process, then 15 goes with 3 only 5 times. So 5.3, we can write 5.3. Now from there are 4 terms, so we are going to take only 2 terms, and 2 terms, first 2 and last 2. You can clearly see from first 2 what is common. From first 2, that's 2 is common, isn't it? 2 is in both terms, so we can say 2 is common, and a is also on both terms. So we can say A is also common. What we have to do to common value, we have to separate it out from the order. So you can see that's the factorization of 2a squared, that's factorization of 6, 5a and 15. Now let's take common from first two terms. Uh, 2a is common. You can see 2 is taken from here, and a is taken from here and here. You can see by the arrow, and 2a is common, so the remaining is a minus sign is written, and 3. You can clearly see the remaining value, and from last two you can clearly see 5 is common. This 5 is common, and 5 we can write right here, and the remaining is a minus sign and 3, isn't it? Now our 4-term question is now changed to 2 terms question, and from these 2 terms also we can clearly see a minus 3 is common. So let's write. Now same thing is there. Please note our 4 terms question changes to 2 terms, and a minus 3 is common in both terms. And now on these 2 terms also a minus 3 is common. You can see a minus 3, and a minus 3 we can write here. A minus 3 is common, and 2a, remaining 2a, you can see remaining 2a right here is written here, and plus 5 is also remaining, it's written here. So this concludes our answer, isn't it? That's our answer. You can write in a fine way also. A minus 3 without dot sign, there is dot, 2a plus 5, 2a plus 5. Now let's move forward. There is another example, example 3, factorization. It's a little bit different, not much. A solution. We can do this by arranging also, we can do as it is also. Okay, now let's focus on single term. This is a 4-term question, so only common must be taken from first 2 term and last 2 term. We can arrange this question and we can do without arranging also. This a can be factorized at a dot 1. It can be written as a dot 1. We haven't written, but we can write a dot 1 here, a dot 1 and b dot 1. Okay, now this a can be written as a dot 1, b can be written as b dot 1, and a square, a dot a, and minus sign, a dot b. Now from first two, what is common? If nothing is common, then we can conclude that 1 is common. So 1 is common from first two, and a minus b, you can see 1 is common from first two, and a minus b, and a is common from second two, a and a is common. That common a is written right here, and the remaining remaining from the third term, you can say this is the third term, is a, and that is, and b from here. Okay, this is not the line, you can write the remaining. And our 4-term question, it's a verification. If nothing is common, then 1 is common. We have already taken 1 as common because nothing was common between a and b, and if nothing is common, then 1 is common. So remaining is a and b. Okay. I always draw this line. So our 4-term question changes to 2-term, and from these 2-term also a minus b is common. So this a minus b can be written as right here, a minus b, isn't it? A minus b, and remaining is 1 plus a. You can clearly see remaining. The remaining is 1. The remaining is 1 from here, and plus a from here. Now this is our answer. So there are only 4 steps, and we conclude this part of algebra. And hope you understood, and I hope that you will make a very proper note of it. And note making is very important, and understanding is more important. Type 1 section B, these are the example for type 1 section B. Factorize. All questions are 4 terms question, and in this question what we have to do is only on question number 4 just arrange this. Okay? Arrange this value and this value, because so that you can avoid minus sign from between. Interchange this position and take sign with them. All other are simple, only 4. So thank you for being with me, and see you on part 2 of algebra.